Okay girls, so we've done the family of alkanes, we've named them, we've drawn them from symbols and structures. So we're on to the second family now, and there are only 2 families done this year. There are another 8 families that you do next year in organics, and the second group that we're looking at are alkenes. So the names now all very similar. This time it's E-N-E-S at the end. So your writing is very important, that you literally, when you're writing alkane or alkene, you're very precise with what you're writing. Okay, so this is alkenes. So this group is another homologous group. So again, from the definition that you've already got, a homologous group is a group of molecules that all share similar properties and get bigger as they go up. And they have the same general term and same general properties. So an alkene, whereby an alkane all had single bonds, an alkene has a double bond. Okay, so it has one double bond in the molecule, and that's what makes these ones all the same. Okay, so if you start, you have to have a double bond between 2 carbons. So the first member of this group that you can possibly have is ethene. That is with 2 carbons in it. You cannot have methene because you have to have a double bond between the carbons, and there's only 1 carbon. So the first member of this group is ethene, and it looks like that. Again, H's are here. I'm not going to put them in from here on in. Okay, the next one that you've got is propene. So you've got 3 carbons, and you can put your double bond here or here. It makes no difference. But once you choose where you put your double bond, it makes a difference to the rest of the molecule. So I have 3 hydrogens here. So 1, 2, 3, 4 bonds. 1, 2, 3 already. So there's only 1 space for a hydrogen here. And 1, 2, 3, 4. Okay. So there's still only 4 lines out of each carbon. And that's exceptionally important. So the formula for this one is C2H4. The formula for this one is C3. H, you count the H's, 1, 2, 3, 4, 5, 6. All right. The next one then, so ethene, propene, then you've got butene. And you don't have too many of these to do, or at least you don't have to go as far as 8. You only have to go as far as butene. So this is the last one where there's 4 carbons. Sorry, I was just checking. From my notes, I can never remember. Okay, so how many of them you have to do? So you've got 4 carbons, and it's butene. So you've got to be careful where you put the double bond. Butene is a general term, and then you have different ways of calling it. So the first one I'm going to do is but-1-ene. And that tells me at carbon number 1, I put the double bond. Now, if I put the double bond here, it is still but-1-ene, but I'm labelling the carbons now this way. So this one and this one are exactly the same. Okay. They're just orientated the other way, so you've just flipped them over. And again, if I can get these molecules, I'll show you can actually physically see that. Okay, so you just turned it like that, but it's the exact same thing. It's called but-1-ene because I'm telling you by writing that one there that I want you to put the double bond at carbon number 1. Okay, to finish it off then, I've got 1, 2, 3, 4. So that's 4 bonds off this one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And again, hydrogens all the way around here. Again, if you were to do it here, it's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And that's but-1-ene. Okay. You can also then have but-2-ene. So this is where you have 4 carbons again, but I'm telling you I want you to put the double bond at carbon number 2. Now there's only one version of this, okay, because you cannot do it any other which way. If I go this side, it's still there. That's carbon number 2. Okay. Again, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If you look at all of these, they are all C4H8. So if you count the amount of carbons and hydrogens, they're C4H8. But they do have different arrangements. This one is different to this one. Okay. When they have the same formula, so they're both C4H8, but they arrange themselves slightly differently, they are known as structural, so structural because you're changing the structure, isomers. And this is a word you need to know. Okay? An isomer is something that has the same chemical formula but has a different arrangement. So they're both C4H8, but they are slightly differently arranged. And you might say to me, well, Miss, now really, like, that's very little of a difference. Why do we need to go into this? But we do, because if we look at these compounds, these two, butyl-1-ene and butyl-2-ene, they react slightly differently. So we have to talk a little bit about what this double bond means. Sorry, just getting a highlighter to highlight what this means. So this double bond here is something you didn't have when you were dealing with alkanes. Okay, and alkanes, because they didn't have a double bond, they were known as saturated, as in they were totally full. The only way you could change them was to take something out and put something else in. This time, however, they're not completely full. So this orange part of your molecules, or your double bond, makes the molecule unsaturated. And unsaturated means that theoretically, and it doesn't happen all the time, but most of the time, when I have a double bond, if I was trying to react this compound, all I have to do is break that double bond and change it to a single, and then I can add two more things on, here and here. So I have two spaces. In the previous examples with the alkanes, I didn't have any space. Okay, when I had butane, for example, I had 4 carbons and they were surrounded by 10 hydrogens. There was no space. Here there is a space there. So if I was a compound coming along, for example, a bromine, a BR2 very much likes to react with these compounds. If I was BR2 and I was coming along, I'd say, look there now, there's a little gap. Okay, so I could fit in there if I could just get that double bond to break to a single bond. This carbon would need another space. This carbon would need another space. And I could fit myself in there nicely. And that's what we call an unsaturated compound. The big thing about unsaturated compounds is they are more reactive than alkanes. They undergo a different type of reaction. So in the previous example, when you had an alkane, they underwent what we call a substitution reaction. You had to take something out to put something in. These ones undergo addition reactions. So that is where I can add something in without having to take anything out. They're much easier to perform. So compounds prefer that. So I'll give you an example in the real world or in the real life. Okay, so for example, we'd say I had a chemistry class coming into me now in 5th year and there's 24 girls in that class. And I have, I don't know, let's call her Josephine Owens. And Josephine Owens wants to join my class. I say to her, no, I'm sorry, Josephine, I'm full. And Josephine says, but I really want to join. A substitution reaction is where I say to the class, somebody has to leave to let Josephine in. Josephine's my neighbour, my best friend, and I need Josephine in. That's very uncomfortable. Someone has to give up their space to get in. So that's very hard to get anybody to do. Because maybe all 24 girls in that room really need chemistry and really want to be there. So it's hard to get that done. The alternative, this addition reaction, is much easier because it's a room where I have 16 girls and Josephine Owen comes and says, I really want to do chemistry, miss. And I say, sure, come on in, join. I'm not full. I've got, I don't know, what did I say, 17. I've got 7 spaces free. So sure, join. That's a much easier system to manage. Much nicer. Much fairer. So you find with these compounds that are unsaturated, that is, has this double bond, that they react more and they do more chemistry, so they're more useful for us. So we are going to focus in quite a bit in this area in alkenes, because alkenes are more reactive, they do more stuff. Things that they do, for example, is a load of them can join together, hundreds and hundreds and hundreds of them, and they can make hard compounds such as plastics. So that's what a plastic is made of. For example, polyethene. So poly means lots of, ethenes joined together and stuck together across this double bond. You break the double bond and you just add a load of them on. And that